Hello, 8th graders. We are in section 12.7, which is the last section of this chapter, and it covers dilations. Unlike all of the other transformations we talked about, a dilation is not a rigid motion. A dilation is a transformation that changes the size of a figure, but not the shape. The image and pre-image are similar. Now, you do not need to write any of this down. We are actually going to go over this in class tomorrow. But a construction, we're going to actually construct dilations. And in this case, we're going to dilate a figure by a scale factor of 2. So you can kind of see what we're doing here. We're going to draw a triangle and a point outside the triangle. The point is called your center of dilation. Then, using a straight edge, we're going to, from that point, draw a ray through each vertice of the triangle. Then we're going to measure the distance from each point to each vertice, and then we're going to double it since we're doing a scale factor of 2. And then we're going to mark the doubling part of it with the red mark, or a new arc, and then those are the new vertices that we connect to make the new triangle that is similar to the blue triangle. Don't worry if you didn't follow along with that. We are actually going to do that in class together tomorrow. All right, there's a lot of stuff to go over here. A dilation, or a similarity transformation. So dilation is not a rigid motion, it's a similarity transformation. Is a transformation in which the lines connecting every point P with its image, P prime, all intersect at point C, called the center of dilation. Now, if you'll notice here, it says the distance from C to P prime divided by C to P is the same for every point. That's the ratio. So if you took, for example, the picture here, the distance from C to P divided by the distance, C to P prime, divided by the distance of C to P will be the same as C to Q prime divided by C to Q. Because if I would double this, let's say I multiply by a scale factor of 2, this distance divided by CP would be 2. The same thing would be true here. If I took CQ prime divided by CQ, it should also give me 2. The scale factor, K, of a dilation is the ratio of a linear measurement of the image to a corresponding measurement of the pre-image. In the figure, the K, which would be your scale factor, could be represented by P prime Q prime divided by PQ. So a dilation enlarges or reduces all dimensions proportionally. A dilation with a scale factor greater than 1 is an enlargement. It says this is a vocab word. You don't need to know that. You know that an enlargement means it gets bigger. A dilation with a scale factor of between 0 and 1 is a reduction. Obviously, if you multiply it by a number that's greater than 1, it's going to get bigger. Less than 1, but greater than 0, is going to get smaller. In the first example, which you do not need to write down, this is on page 873. It says that an artist is creating a large painting from a photograph by dividing the photograph into squares and dilating each square by a scale factor of 4. If the photograph is 20 centimeters by 25 centimeters, what is the perimeter of the painting? Now, this really is that easy. If we're multiplying by a scale factor of 4, we multiply each dimension by 4. So that gives me 20 centimeters by 100 centimeters. And obviously, if we added up all 4 sides, we could take 100 plus 80, which is 2 sides, which is 180, times 2. And that gives me a perimeter of 360 centimeters. Now, that's a really easy problem. The harder problems in which we're going to use a compass and a straight edge, we will do that tomorrow, so leave room in your notes for that. But let's go on to the next example. Dilations in the coordinate plane. If we have a point P, which is at XY, which over here is located right here. If that is the pre-image of a point under a dilation centered at the origin with a scale factor of K, then the image of the point is P prime. All we do is take the scale factor and multiply it to each coordinate. And that's it. We take our XY, we multiply it by our scale factor, and that gives us our new point. Now, if the scale factor of a dilation is negative, the pre-image is rotated by 180 degrees. So, for example, if I have a pre-image and the scale factor K gives me this green quadrilateral, if I have a negative, it rotates at 180 degrees. So, for K is greater than 0, a dilation with a scale factor of negative K is equivalent to the composition of a dilation with a scale factor K that is rotated 180 degrees, about the center of dilation. So all it says is, if you have K, for example, if it's negative 5, the green would represent times 5, and then the negative rotates the green image about the center of dilation. Example 2, drawing dilations in the coordinate plane. We want to draw the image of the triangle with vertices A, B, and C is given under a dilation of a scale factor of negative 2, centered at the origin. So the first thing I'm going to do are graph the points A, B, and C. So A would be negative 1, 1, B would be negative 2, negative 1, and C would be negative 1, negative 2. I'm going to connect them. And then I'm going to write them down. So A is negative 1, 1. Now, if I multiply by negative 2, all you do is using the arrow notation above, all you do is take the K, which in this case is negative 2, and you multiply it by both the X and Y coordinate. So A prime would be positive 2, negative 2. B, which would be negative 2, negative 1, if we multiplied both negative 2 and negative 1 by negative 2, that gives me 4, 2. And then C, which is negative 1, negative 2, would give me C prime, which is 2, 4. So if I graph those, 2, negative 2, which is A prime, B, which becomes B prime, which is 4, 2, and C prime, which becomes 2, 4. I connect those. Now, notice what happened. The red image is double the size of the pre-image. Because it's negative, the entire shape rotated 180 degrees about the center of dilation, which was the origin. So the blue image rotated and doubled 180 degrees about 0, 0, which is the center of dilation. The only vocab word you have from this section is dilation.